Hello and welcome to another episode of Momento Malum today. One of the great ambitions of the breeders of garden ornamentals is the creation of ever larger flowers. One of the easiest ways to breed for this trait is by increasing the chromosome number. This increases the size of everything: leaves, bulbs, and most importantly, flowers. The norm for many of our crop plants is diploid. One set of chromosomes from one parent and one from another. Polyploids are an exemption to this above system. Triploid plants are plants that have received two chromosome sets from one parent and one set from another. And tetraploids receive two chromosome sets from both parents. In a garden context, these lines are examples of plants with the biggest flowers. The common means to create these lines is the application of anti-mitotic chemicals like colchicine to seeds or tissue culture samples to cause an increase in the chromosome number. The paper being referenced lays out a series of experiments alongside an experiment on tulips, and here are the results. In the tulip experiment, the cultivar fringed black, an experimental line, it was found that when the tissue culture cultivar lines were exposed to the anti-mitotic agents, the amount of polyploids being produced through this process was between 28.6% and 33.3%. This was a common range found for most species. Flowering quince is a production rate of polyploids between 10 to 40%, around 40% in kiwis, and 50% in onions. There are several species that are on average lower than tulip, such as the calla lily at 20%, 18% in rhododendron, 12% for lily of Incas, 20% for daylily, and 27.5% for both Lenten rose and buttercup. Overall, different cultivars and different species respond differently to the tissue culture processing used to create polyploids, with some cultivars being more successful than others, with the experimental line being poorly suited for the tissue culture polyploid creation process, and the tulip cultivar fringed black doing quite well with it. This is common. Different cultivars and different species take differently to tissue culture, and there's a great deal of variation in how well tissue cultured plants take having their chromosome number mucked around with. And that about covers everything. Thank you for watching. If you want to donate to my channel, the links are below. If you want to buy my book, you can also find that link in the description box below.